Welcome. Now we're going to discuss the complex number system, specifically the imaginary number I. So the main thing that we need to know is that I represents the square root of -1. And of course, we know we can't take the square root of a negative number. So we use the square root of -1 to continue solving problems once it seems like we would be stuck and we would have to stop. So it allows us to find, in a sense, the virtual roots. The imaginary number I was invented purely for mathematical reasons. Um, it was found just because there were some ugly asymmetries that existed only with real numbers. And when we were trying to solve quadratic equations, which is what we're building toward, but a long time ago, trying to solve quadratic equations, not all quadratic equations had two roots. So in a sense, this was a way that we could solve and create two solutions for a problem that we knew must have two solutions, but did not have two real solutions. One question or comment I always get about imaginary numbers is, when are they useful? Well, they're used a lot in electricity as well as electrical engineering. And, they're found, as I've already said, in quadratic equations. Once you move into advanced vector calculus, the imaginary number I can become very useful in that regard as well. All right, so now that we've talked about the imaginary number I, and you guys are going to remember that I equals the square root of -1. Let's talk about the fact that I squared equals -1. Well, if we know that I equals the square root of -1, well, if I were to square that, that would mean I squared becomes -1. How about if we wanted to find I cubed? Well, I cubed could be written as I squared times I. And as we've just stated here, we know that I squared is going to equal -1, and I is defined as the square root of -1. That means that I cubed is negative the square root of -1. Going a bit further, thinking about I to the fourth. I to the fourth could be written as I squared times I squared. And we already know what I squared is. We've just found that over on the left side of the screen. I squared is -1. So -1 times -1, that will provide us with an output of +1. And we could continue deriving in this sense infinitely. So the idea here is, just by starting with I, we developed I squared, which we use so often we tend to remember. But I could also develop I cubed, I to the fourth equal to 1, I to the fifth. Well, I could say I to the fourth, which is 1, times I to the first, which is square root of -1. Right? So we can continue doing this forever and find infinite values of I. And what you'll notice is that it starts to become circular or repeat itself every fourth I. So thinking about this definition, again, I've cleaned the page up here, but we have I squared, I cubed, I to the fourth. And if we continued deriving in the previous method, we would find that I to the fifth turns out to equal I to the sixth turns out to equal I squared, I to the seventh, I cubed, I to the eighth is equal to I to the fourth. We could go further and say, well, this must be I to the ninth, I to the 10th, I to the 11th, 12th. And as I said, we could do this all day, which is not what we want to do. So here we're given a problem. We're asked to simplify I to the 401st power. So we need to think about a way to solve this without having to count, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I don't want to do that. Well, let's think about what or how often, I should say, this I is repeating. And it's repeating every 4 times. So if I can take this and take 401 divided by 4, we're going to be able to show that the remainder is going to be the I value that it's equal to. So if I take 401 and divide that by 4, well, I'm going to get 100. It goes in there 100 times evenly, and I'm left with a remainder of 1. So in a sense, I could say that 401 is equal to 4 times 100 plus 1. Now, we like I to the 4th. I to the 4th is just equal to positive 1. So let's look at this. I to the 401, well, that's the same as I to the 4 times 100 plus 1. Noticing here that all of this is in the exponent. And when you are multiplying same bases, you end up adding the exponent. So I'm going to rewrite this. This is actually I, we'll say to the 4 times 100 times I to the 1. So I used properties of exponents to expand this. And of course, also with properties of exponents, we can note that a power to a power is the same as multiplying. So we have I to the 4th to the 100th times I to the 1st. And of course, I don't need to write that first power. Remember, I to the 4th is equal to positive 1. So this means I have 1 to the 100th times I. 1 to the 100th is just 1, and 1 times I would equal I. Therefore, I to the 401 is equal to I. And essentially, that I to the 1st, that 1, that's coming from the remainder when you divide by 4. So if you do have any problems where you have I raised to a power, just make sure you can divide by 4, whatever your remainder is, that's going to be the I value you could reduce this to. So the main thing that you as a student need to be taking away from this video is that you know these 2 pieces of information in the box and commit them to memory. And essentially, as I already said, you really only need to know the fact that I equals the square root of -1, and you can always square it to determine what I squared is. But as a longtime teacher, I will encourage you to make sure you memorize both of these values. I is equal to the square root of -1, and I squared is equal to -1.